This one is June 2020. Two equal positive charges are placed at Y and Z. Point X is equidistance. Which of the following shows a direction of the electric field? Look, when we sketch a direction for a positive charges, like charges repel. This is the pattern we will have for electric field, and the direction is always pointing outward. So at this point, how the direction, resultant direction is there, so that is pointing downward. So this will be the right answer. Is it clear? Next, we have student writes the following equation. Which of the following conservation law violated? Baryon number for every, like neutron has a baryon number of +1. Electron and electron neutrinos are leptons, so they don't have a baryon number. Baryon number is conserved. The charge, this is 0, +1, -1, and 0. The charge is conserved. Energy is always conserved. Like you cannot identify energy from their this equation. The main thing is the lepton number. If you see for every lepton, it is +1. And these are baryons, so they don't have any lepton. For this is +1. And anti-lepton, this is also lepton, so there's also +1. So lepton number is +2 on the right and it is 0 on the left. So the lepton number is not conserved. That's why D is the right answer. A potential V is connected, a potential difference V is connected across a capacitor of a capacitance C. The charge stored on the capacitor is Q. The parallel capacitor is replaced by two capacitors which are having each of capacitance 2C in parallel. What is the total energy stored? We have the formula that energy stored in the capacitor is half QV. But we don't have Q. Q is equals to CV. So we can say energy stored in the capacitor is CV square. As they are connected in parallel, they will have the same word. So energy stored here in this combination is half CV square. Energy stored here because what happened? The capacitance is double 2C. So the energy stored will also be twice. And if you want the question was total charge actually. So if I need a charge, I will just use the formula that Q is equals to CV. That is the total charge stored here. What about this one? If you check the total charge, because the capacitance is double, so the total charge will be 2Q here. Because if C is double, Q will also be double. V is constant. And this also will be 2Q. So each is storing 2Q and 2Q. What is the we need a total charge stored, so the total charge stored will be 4Q. Like because 2Q here and 2Q here, the total will be 4Q. SI unit of capacitance is farad. Which of the following is the base unit? So Q is equals to CV. C is capacitance. And we have Like I is equals to Q divided by T. So Q is I multiplied by T is equals to CV. What about voltage? Like voltage is work done per unit charge or energy divided by charge. I can write the units first and then simplify the units, or I can also solve with the quantities. Or in place of V, I can write IR. This I will cancel with I. So it will be T over R is equals to C. What is R here? Instead of doing lot of things like Q is equals to CV, Q over V is equals to C. Q is the charge, which is a current multiplied to ampere second. V is the voltage. Voltage is energy per unit charge. Means joules per coulomb. So this will be joules per C, or I can say ampere second times coulomb joules. What is coulomb? Coulomb again ampere second. So this will become ampere second square, ampere second and ampere second divided by joule. So this will become ampere second, ampere square second square. Now what about joules? Joules is Newton meter, and Newton itself is kilogram meter second raised to power minus 2. And the joules itself is kilogram meter square second raised to power minus 2. So if we simplify this, like this will be ampere square second minus 2 become plus 2, so it will become second 4. It will be kg kilogram minus 1 meter minus 2. So kilogram inverse meter minus 2 second 4 ampere square. So it matches with option C. Is it clear? The base unit of capacitance. The next is a gas molecule of a mass m traveling at a speed. What is the average force exerted on the side of a cylinder? So if this is V, it will have a component opposite to the angle. This will be V sine theta. And this will be minus V sine theta because it is an opposite direction. So if we take the difference, because the magnitudes are the change in because impulse is a product of force and time. If I need a force, impulse divided by time, I'll get the force. Impulse is a change in momentum, final minus initial. So mv sine theta minus, and then minus, like if this is positive, so we'll take mv sine theta minus and then minus mv sine theta. Why? Because it is in opposite direction, this one, divided by time. So when we simplify, it will become mv sine theta plus mv sine theta divided by 2, divided by t. So 2 mv sine theta divided by t, so it matches with option D. Is it clear? But some mv sine theta is the final velocity. Yeah, the thing is, because in the question they just need all the options are for magnitude, not for direction. That's why I can take any one of them as positive. Like if I take this as negative, this one I'll take as positive. So it does not make difference here because main thing is the magnitude rather than the direction specified. Is it clear? But shouldn't we do up minus? No, in the question they did not said that which direction to be positive. Like if the question was specific that the right hand direction is positive and the left hand direction is negative, because this velocity will have the two component. One is with an angle, so that is v sine theta, and this one is also v sine theta. But because they are in opposite directions, so if I'm taking this as negative, this will be positive. If I take this as positive, the other one will be negative. So when I work out, because when direction change, the momentum will be the 2m, like twice. The main thing is the idea about not the direction, it's about the magnitude in the question. If the question was specifically direction related question, then they will specify that. But in the top one, yeah, top one is a final. So you can take, this is the initial velocity, this is the final velocity. This initial velocity will have the component, the one which is with an angle, that will be v cosine theta, and the opposite to the angle is v sine theta. Same thing here, this will have the two component with an angle v cosine theta, and opposite to the angle is v sine theta. Now the two are in opposite direction, so it's up to me that which one I want to take positive, because in the question they did not specify. So if I take this as negative, I'll take this as positive. Or if I take this as positive, the other one is negative. So when I use a final minus initial, so minus 2m, like I will take as minus mv sine theta minus mv sine theta divided by t. So again, it will give me 2mv sine theta. Negative sign only shows the direction, but I'll get the same result. All the options are in magnitude. That's why I will get the same result. So it won't make difference that which one I take positive, the other one will be negative. Again, we have oil charge is there. What is the charge on the oil drop? According to this electric field strength E is equal. Here, electric force, an oil drop of a charge Q of a mass M. So electric force is equals to weight. Electric force E is equals to, sorry, electric force F I should write. So electric force is equals to weight, because this is kept stationary. Electric force E is equals to F over Q. So F is E multiplied by Q. So EQ is equals to weight. And between the parallel plates, V is equals to ED. So E is equals to V over D. So V over D into Q is equals to weight. Then weight is mass times the gravity. So VQ over D is equals to mg. If I need Q, so it will be mgd divided by V. So mgd divided by V. So it matches with option C. Is it clear? Discussion? Here, a proton enters a magnetic field. So whenever you need the force on the charge entering a magnetic field, you will use a Fleming's left-hand rule, a positive particle. But this proton will have the two component. One of the component is perpendicular, another one is horizontal. The horizontal component will cause a deflection, like movement towards right, and vertical component, this component cause a force. So how the proton will move, it will move in a spiral like this. Why it will be look, if there was a magnetic field and the proton was actually entering perpendicular to the magnetic field, then it will only follow one loop. Like it will just move in a circular path. But here it is entering at a certain angle, so which is having two component, horizontal and vertical, which cause the proton to move in this way. So which of the following gives the direction of the force on a proton as it enters the magnetic field? So we just need a direction of the force using your left hand rule, index finger, and we take a perpendicular. If it enter parallel, it will not cause any deflection. Like if proton is parallel, it won't cause any deflection. If it is perpendicular, it causes deflection. And if it is making an angle, so you use a left hand rule, your index finger point towards the direction of a magnetic field. second point in the direction of a proton. Where your thumb is pointing? Your thumb is pointing into. So how to know that? You will take a component. You take this component, like this is the direction of the proton, your second finger. This is your first finger direction. Work out where your thumb is pointing. You will find your thumb is pointing into the page. Is it clear? Left hand for positive and right hand for negative. Yes, that's right.